So today I'll be talking about energy, which is syllabus number 1 of Unit 2. First, I'll begin with the definition of energy. I'll address two basic forms of energy. We'll specifically look at chemical potential energy, and then I'll go over the law of conservation of energy and what that means, who it was founded by and when. And lastly, I'll go over differentiating energy units, how those relate to each other, and how to convert between one and another. So energy is the ability to do work or produce heat. Work is defined as force times distance if that force is constant, meaning there's no outside friction working on it. There are two basic forms of energy. It includes potential energy and kinetic energy. Potential energy is stored energy and is due to the composition or position of a substance or object. Kinetic energy is the energy of motion. This image shows how potential energy is when the ball is held, and kinetic energy is when the ball is dropped, as that motion of dropping the ball is defined as kinetic energy. So a specific type of potential energy includes chemical potential energy. It is the energy stored in a substance because of its composition. This energy is stored in the bonds of the substance. This image shows how when the bonds are broken, the energy is released. And different amounts of energy is released, and it takes different amounts of force to break different types of bonds, which you will learn later on in this class. So an example of chemical potential energy includes a battery. Now, alone, a battery isn't doing anything, but once that circuit is connected between the cathode and the anode, when it is inserted into whatever you're putting it in, there is a chemical reaction that occurs inside the battery, specifically in the electrolyte, where bonds are broken and energy is released. Now, this is specifically defined as within a battery, a controlled chemical reaction takes place that creates electricity, which can produce heat or perform work, as we've seen before with the definition of energy. Now, a law that was founded in 1845 about energy is called the Law of Conservation of Energy. It was founded by James Joule, who lived from 1818 to 1889. He was an English physicist and a mathematician. The law defines that in any chemical reaction or physical process, energy can be converted from one form to another, but is neither created nor destroyed. This equation seen here defines this law as the initial amounts of kinetic and potential energy equals the ending amounts of kinetic and potential energy. There are many different units to define energy, and they relate in many different ways. So I will go over them. We are given 5 basic definitions that you should know. So there are 3 main units to describe energy, and that is calorie, a joule, and a nutritional calorie, which has that uppercase C. And these relate as 1 calorie equals 4.184 joules. 1 joule equals 0.2390 calories. 1 nutritional calorie equals 1,000 calories. So 1 nutritional calorie equals 1 kilocalorie. 1 kilojoule is equal to 1,000 joules. Further definitions and things you can know. 1 joule is equal to 1 Newton meter. The SI basic unit for energy is joule. And 1 calorie is defined as the amount of energy required to raise the temp of 1 gram or 1 milliliter of water by 1 degree Celsius. So now we will go over some conversions between these units. First, convert 250 calories to joules. You can pause the video to do this. So you would use the equation 250 calories times 4.184 joules, which is the relation between 1 calorie and however many joules. That would equal 1,046 joules. Next, look at 20 nutritional calories to that basic calories. You would use the equation 20 nutritional calories times 1,000 basic calories because 1 nutritional calorie equals 1,000 basic calories. And you would find that 20 nutritional calories equals 20,000 basic calories. Lastly, convert 35 joules to calories. You would use the equation 30 joules times 0.2390 basic calories because 1 joule equals that amount of calories. And you would find that 35 joules equals 7.17 calories. Next, I'll provide a real-world example. So you can convert the amount of calories in your food to joules or regular calories, but always remember the calories in food are a nutritional label. Those are nutritional calories with that uppercase C. So they're much larger than basic calories. So looking at this nutritional label, find how many joules from fat are in 86 grams of the food. So a little hint here is to pay attention to the serving size on the label. You can pause this and then I'll go through it step by step. So first you see that in 86 grams of the food, it is 2 servings because 86 grams divided by 43 grams, which is the serving size on the label, equals 2. So in this equation, you'll be focusing on 2 servings of the entire thing. Next, you have to convert these 2 servings to however many calories from fat there are. So pay attention to there are 8 calories from fat in 1 serving. So in 2 servings, it's going to be 16 calories, nutritional calories from fat. Next, you'll have to convert these nutritional calories to basic calories using that definition of 1 nutritional calorie equals 1,000 basic calories. And you'll find that 16 nutritional calories equals 16,000 basic calories, as seen here. So lastly, you will want to convert 16,000 calories to joules by using the relation that 1 basic calorie equals 4.184 joules. So hopefully you figured that out. And you did 16,000 times 4.184 joules to find that there are 67,000 joules in 86 grams of the serving from fat. Thank you so much. I hope this helped you a little bit through your journey of chemistry.